Now we study logarithms. We have 9 examples here. Logarithm base A of B. So this is the base, and this log is short for logarithm. So log base A of B is the exponent we put on A to get B. And it turns out that A has to be greater than 0, and B has to be greater than 0 for reasons we'll see. So example 1. Log base A of 1,000. The base, the way you write it is you have a line here going across here, and log is on top of the line. Let me draw that with a different thing. It's like a imaginary dashed line. You don't draw that, but the log would be sitting on the line. The number inside here would be sitting on the line, and the base would be below the line. That's how you do it. So it's the exponent we put on 10, the base 10, to get 1,000. So then, rather than saying that around your head 50 times, you write it down. What number do you put on the base 10 to get 1,000? And you can see that 10 to the third is the number. 3 is the number that you put on the base 10 to get 1,000. And if you didn't see that, you would have to write 1,000 as 10 to the third, and then you'd match up the 3 and the 3. So then the final answer to log base 10 of 1,000 is log base 10 of 1,000 equals 3. The exponent you put on the base 10 to get 1,000. So logs are exponents, and they're going to follow all the exponent rules too because of that, which we'll get into later. Example 2. You can have all kinds of different bases. Log base 2 of 16. The exponent we put on 2 to get 16. So the base 2, what do you put on the base 2 to get 16? 2 to the fourth is 16. So log base 2 of 16 is 4. The exponent you put on the 2 to get 16 is 4. Example 3. Log base 3 of 1/9. The exponent you put on the base 3 to get 1/9. What is that? We have to rewrite 1/9 in terms of the base 3. 9 is 3 squared. 1 over 3 squared is 3 to the minus 2. And you have a base here 3 and a base here 3. So what has to go up here? Negative 2. 3 to the minus 2 is 1/9. So log base 3 of 1/9 is minus 2. The exponent you put on 3 to get 1/9 is negative 2. 4. Example 4. Log base any base of 1. So that means a to an exponent has to be equal to 1. What is that exponent? 0. So log of any base of 1 is always going to be 0. Example 5. Log base any base a of negative 2. So you say the base raised to this exponent has to be negative 2. Well, that's impossible. You can't get negative. Like if you have a base like 3, what are you going to raise it to get a negative number? If you put a negative number over here, that's just 3 to the minus 2, which is 1/9. That's a positive number. No matter what you put up here, you're going to get positive. So how can you get a negative number? You can't. So this log here of a negative number is undefined. Undefined. So when you have log base a of b, we realize that b cannot be negative. Example 6. Log base a, any base, of 0. So a raised to a number has to turn out to be 0. Again, there is no such number. Even if you have something like 10 to the negative 1,000, you try for a real big exponent. That's still 1 over 10 to the 1,000, which is getting very small, but it's still positive. You cannot get 0. It's never going to be 0. So log base a of 0 is undefined. So in log base a of b, b cannot be 0, and it can't be negative. In other words, b has to be greater than 0. Example 7. Log of a number. Where's the base? Well, when it doesn't have the base, that's shorthand for log base 10. So log of a number means log base 10. LOG means log base 10. And it's also called the common log because it's commonly used. Log base 10 is called the common log. So then we have example 8, log of 0.0001. And we know that means base 10. So it's the exponent you put on a 10 to get 0.0001. What exponent is that? Well, you have to rewrite this in scientific notation as 10 to the minus 4, and it's minus 4 because you have 1, 2, 3, 4. So it's negative 4. So what number has to go up here? Negative 4. So log of 0.0001 is negative 4. Last example here. Log, this is base 10, but it doesn't say it, of this quantity here. So we will say 10 to the what exponent is this number? Well, we have to simplify this number, and we're looking for exponents, so we change this radical into an exponent, 1/4, and then we have to express the 0.01 scientific, that's 10 to the minus 2, and that's to the 1/4 power, so it's 10 to the negative 2/4, and we reduce that to negative 1/2. So negative 1/2 is the number that had to be put up there to equal this. So we have our outcome here. And let's verify with the calculator. All these could have been verified in the calculator. Even the ones with non-base 10, like base 2, you can rewrite them by changing the base, but we'll go over that later. So here's how you'd have to write it. And that would be log, and it puts a parentheses, and then you put 0.01 to the up arrow, parentheses 1/4, close parentheses, enter, and that would equal negative 0.5, which is the same as negative 1/2.